Psyche is a unique object in the solar system.
To us, Psyche is this really unusual body giving off really unusual gamma-ray neutron signatures.
Technically, it's an M-class asteroid out between Mars and Jupiter.
One of the first things you want to know is what's it made of.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma-ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma-ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history and how it formed and how it evolved.
By using gamma-ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call the Cadillac. It's a very high precision, high sensitivity instrument. It's very similar to the MESSENGER instrument.
That technology that we developed for the MESSENGER spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around externally.
You have galactic cosmic rays. That's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart the atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays and neutrons that come out. And the gamma rays have energies, and they're like a fingerprint. So if you get the fingerprint of different energies, it says, is iron there, is nickel there, is silicon, and then how many of those gamma rays tells you how much of that element is there.
The first thing it takes to do a mission like this is a tremendous amount of institutional knowledge of all the different aspects, not just how do you build something, how do you aim something, how do you guide something, how do you get data from something, those technical aspects.
I feel like it's super important to have a team that you can trust, because you can guarantee that at some point something's going to go wrong, probably many things over the many years of a project. So already it's happened that in my process of learning about the science, I've made small changes to the design to help optimize and help meet the science goals.
We're kind of the last instrument to get its measurements.
And so there is a sense where you're on pins and needles until you get that data back, and then there's a big relief, there's big excitement, and then you get to work and trying to say, what does all this mean?
So we'll deliver some excellent science at the end.